Many of us have been, in various ways, bemoaning the state of our field. If any of you have had a house with a vermin problem, you call some pesticide management company. The best ones do what they call integrated pest management. So I think that word integrated is important to consider how the history of science was. When I came to Toronto, still not having finished my dissertation in 1969, Stillman Drake was already there. And as you all, I'm sure, know, besides, I mean, he'd never been an academic before, but once he got interested in Galileo, he not only taught himself Italian, he also began to do experimental replication. And of course, with his book collection and learning everything he could about Galileo's time. Certainly, it's important to remind ourselves that the history of ideas was before that, and by the late 60s, we well understood that besides the internal history of science, we needed to complement, we need to integrate it with external history of science. And besides, within our field, or any field of science, the people who are particularly good at the ideas and theories and indeed experiments, you also need people who are good at management and administration. And in Toronto, that was Ken May, even though he was director for only, I think, 2 years before his early death. He was sharp enough to notice that Stillman and Trevor and I, there were a series of us who were going to be off for a year in a row. So he said, aha, I will advertise for someone to come for 3 years and not 1 year on this brief slot. And by the end of that time, he said, the deans will have forgotten. And indeed, that's how we first hired Jed, and after a few years had to have a search. Though I met the other day one of the people who applied for the job, sadly not knowing it was already Jed's job. Anyway, I'm very pleased to see you all this morning, and of course, like everyone, I'm delighted to be here, and I'm happy to introduce our first speaker is indeed Sharon Kingsland, who is professor at Johns Hopkins University.
Okay, this morning's panel on mastering the facts captures one of the goals of historical research. We try to understand, as best we can from a distance, how scientific practitioners have gone about the task of explaining how nature works, and that also includes considering the broader social, cultural, economic, and political contexts of science. We want to understand how particular kinds of scientific work have come to be part of our cultural fabric. Now, for me, one of the pleasures of approaching science studies through the discipline of history is that we have so many methods at our disposal to uncover facts that are needed by those other disciplines that are not historical. And if I learned anything as a graduate student at Toronto in the 1970s, and I'm thinking of the lessons I picked up from Jed and also from Trevor Levere and Polly Windsor, who are both here, it's that as a historian, you never reach the point where you think, my historical training has only taken me so far, and to go any further, I have to cede authority to someone from another discipline. I have never thought that. We can have it all. Okay. Historical research and historical methods are the main trunk that supports all the other branches that make up science studies. So because of that very central role that we have of discovering and interpreting new information, it's also important for us to be able to communicate what we do and what we've learned to those other academic disciplines and to people who are not scholars. I'm not always convinced that we do this successfully, and it came up in the discussion yesterday, so I want to come back to it. I'd like to start with the problem of how we might communicate our mastery of the facts. That's going to be important to the future of our discipline, I think. So a recent conversation with Polly Windsor made me think about the question of how historians of science could be maybe a little bolder in communicating, in experimenting with ways of communicating our scholarly work, or using our storytelling methods, because we are telling stories based on, of course, research, how we can explain complex scientific ideas to lay audiences. And Polly recently published an article in Endeavor, which is a history of science magazine for a lay audience. It's a 3-part article that was prompted by a discovery in 1992, hidden in a zoology museum in Cambridge, England, of a taxonomic map or a chart originally made back in the 1840s by a man named Hugh Strickland, who was a naturalist and an expert on birds. And Strickland was trying to create a map in the same way that a mariner might create a chart or a map of the islands and the reefs in the ocean. But in this case, he was trying to depict the relationships between different groups of birds and showing what the affinities were between these different groups. He was struggling with a central problem of natural history. Are the classification systems that we devise artificial, or is it possible to create a natural classification system that expresses the true affinities between species? And then what do those affinities tell us? Do they, for instance, tell us something about the plan in the mind of the divine creator? Well, Polly, after this map was discovered, could have analyzed it in a conventional scholarly type of article. But instead, she framed her analysis as an imagined conversation in the afterlife between Strickland, who's there, and Charles Darwin. Strickland died in 1853 before Origin of Species was published, so his thinking is not Darwinian. For Darwin, affinity meant kinship, relationship. But Strickland, like other taxonomists of his time, was not thinking that way. So what Polly does is have us look at Strickland and his chart through the eyes of Darwin as an old man and interrogate Strickland about what he's trying to do. So it's a creative exercise. Now, right away, Darwin notices a problem in the chart. Okay. Strickland had argued that he was following an inductive method and creating a fairly objective map of this group of animals. But Darwin's observations reveal that that's not right. Okay? Strickland was very clearly also following the customary practices laid down by previous taxonomists. Now, for Darwin, that meant he was actually also importing hypotheses into his chart. Okay? And when Darwin says that, Strickland finds this comment interesting and novel and a bit unexpected. So, by looking at this conversation between these characters, we begin to understand how difficult it might have been for Darwin to break through those traditional practices and to persuade his fellow naturalists that their taxonomic groupings were not always objective facts, but were in fact hypotheses. Not that having hypotheses is wrong. The trick is to know when you have a fact and when you have a hypothesis. So through a fictional conversation that is based on historical research and evidence, we come to grips with the problems that Darwin faced, and we begin to understand why it took him 20 years before he felt he could publish Origin of Species. Now, most commonly, we think of using fiction to create historical reenactments, and this came up in Graham's comments yesterday. This is not a reenactment. It's a fictional episode based on historical research and the analysis of a historical artifact, and it's designed to draw out some larger important points about the practice of science. Okay. Of course, Darwin's insight that it's important to know the difference between a fact and a hypothesis is really Polly's insight. And her comment reminds us that historians are also in the business of distinguishing facts from hypotheses concerning past science. That is, we're trying to understand what scientific practice in the past really involved as much as we can. And in the process, we can offer corrections to people whose interpretations are, in fact, hypotheses. Okay. Now, there's no better, oops, pressed the wrong one there. There's no better example of this corrective function that I want to move to than trying to repeat historical experiments. So I'd like to follow on from yesterday's interesting discussion to develop some additional points about the importance of using these kinds of tools in scholarly analysis. Now, my colleague Larry Principe at Hopkins has for a long time been interested in trying to reconstruct laboratory practices in chemistry. He was invited to the conference, but he couldn't be here today, and so I'd like him to be here at least indirectly, and so I'm going to speak for him here. This topic, Trevor mentioned it yesterday, was the subject of a Dibner workshop on, oops, where am I here? Hang on. A Dibner workshop on instruments and experimentation in the history of chemistry. Trevor mentioned it yesterday, which was published in 2000 in a volume edited by Larry Holmes and Trevor Levere, and I'm going to draw on Principe's chapter in this book. Okay. So Larry Principe, who's here, is a historian of alchemy. And he's long been interested and worried about the difficulty that people have had in taking alchemy seriously as a scientific practice. In part, the dismissal of alchemy is the result of a historiographical tradition that emphasizes the rise of modern science as a discontinuous process. Certain scholars have focused, for instance, on the Royal Society of London, where emphasis was placed on open, witnessed experiments and verifiability, and those are taken to be signs of modern science that are contrasted to the very secretive and obscure world of alchemy. So it's a story of discontinuity, okay? Alchemical texts are renowned for their bizarre imagery and emblematics, and that has always functioned as evidence that alchemy is not scientific, not experimental. In other words, the imagery is the product of imagination, possibly fraud or hallucination. So Larry began replicating alchemical processes to try and figure out how much input there really was from experiment or practical observations. So I'm going to show you two images from these emblems. The first one shows an emblem involving an image of trees, okay? It's the tree here that's important. It's a common image in alchemical texts. And here's another one, more striking. Again, it's the image of the tree, okay? Very, very striking. Okay. Images like this have always been taken as evidence that alchemy is not scientific and maybe is not experimental at all. So you can see how that connection would be made. Principe was trained as a chemist. He has a PhD in chemistry, and he thought there might be a way of understanding these images. So he noticed that in many of these texts where you see these trees, people also insist that a specially prepared kind of mercury and gold was the correct starting materials for the philosopher's stone, and that the sign of initial success was something that was referred to as vegetation of gold. Okay, so the instruction suggested that the alchemists really were experimenting, but they were speaking in a kind of code, and Larry tried to decode those instructions. So he explored those coded recipes to see if he could produce vegetation of gold. And it took him about a month of work in his lab before he prepared what he considered the correct philosophical mercury. He mixed it with gold, sealed it in a flask, and then heated it. So what I'm going to show you here is what he originally mixed up and sealed in a flask. So then he heated it. You get something that looks like this, and if you light it from the back, what you see is something that grows like vegetation, okay? So it was a shock to him to realize that this is, in fact, vegetation of gold. It had the exact appearance of the vegetation described in the alchemical texts. The emblem of the tree has meaning. It's not a hallucination, it's a code for an experimental result. So the methods of chemistry and history, synergistically combined, reveal this bizarre alchemical world in a new light, and they give us a way to appreciate that what these secretive alchemists were actually doing. It looks much more empirical, more scientific, more reasonable than we imagined, and there's greater continuity. The story of early modern science is not necessarily one of discontinuity. There may be more continuity there than we recognize. One of the points that Principe and his colleagues make about this kind of work is that this kind of experimental reconstruction, this is important for us to realize, was for a time vigorously opposed, okay, especially in the 1990s. Criticisms came from proponents of the sociology of knowledge who were insisting that experimental results of scientists were socially constructed, meaning that they were influenced by the social, political, or other non-scientific drivers, okay? And therefore it followed that the experimental results of historians were equally socially constructed. And therefore experiments like this provide more information about the historian than the original experimenter. That was the criticism. So Principe and his colleagues want to argue quite to the contrary, that this is a very misplaced criticism, that instead these kinds of experiments really enrich our understanding, not just of the history, but the sociology of science. They can help us to understand how the practice of scientific work is embedded in artisanal, industrial, and societal networks. There's sociological knowledge here too. The facts that the historian brings to light can also serve the aims of the sociology of scientific knowledge, and there need not be conflict and opposition. So my final example is meant to show that historians have also taken on the challenge of studying contemporary science, and that the study of today's science need not be left in the hands of sociologists or anthropologists of science. It's too important for historians not to investigate modern science too. We have the methods to assess current science, and our analyses can be quite instructive, especially when things go wrong. Okay, so my example comes from the Hubble Space Telescope, one of the recognized great success stories of modern science, and of course for which Caltech has played a very important role as instrument maker. But it didn't start that way. Okay? Many of you will remember that Hubble had a shaky start following its launch in April 1990. By midsummer, images were coming in, and it was clear that something was very wrong. The images were blurred. Hubble could not see. Apparently, it needed spectacles. Okay. It was, in the words of one scientist, like climbing to the top of Mount Everest, and then a couple of months later, sinking to the bottom of the Dead Sea. The problem was in the primary mirror, which was the wrong shape. The instrument maker here was Perkin-Elmer, and the instrument maker had failed to test the shape of the mirror properly when it was made back in 1981. So nearly a decade before the launch, the flaw was already in place. As the problems came to light, the hobbled Hubble was deemed a failure of epic proportions. Senator Barbara Mikulski, who is chair of the subcommittee that oversees NASA's budget, was outraged. Over 10 years of work, more than $2 billion, and it didn't work. Luckily, our legislators didn't need to look very far to find some answers. For a full scholarly history of the Hubble Space Telescope had already been published in 1989, even before the launch. Okay. This history was the collaborative work of historians from my department at Hopkins and the Air and Space Museum at the Smithsonian. These historians took advantage of this extraordinary opportunity to follow a big science project from its early stages with a team of experts in the history of science. Robert Smith, historian of astronomy, led the team, and he was the lead author on this book. The team members immersed themselves in the scientific culture of Hubble for a few years. They watched and listened through countless meetings as the Hubble was being planned. The analysis that informed this book provided an extremely clear picture of the complex processes of this big science enterprise. And in fact, the book did actually explain why things went so terribly wrong, even though it was published before the fiasco. In 1981, there were enormous cost and schedule pressures that were so great that people thought the project would be canceled. In this climate, corners were cut, tests were not duplicated. One of the historians remembered attending a briefing by a Perkin-Elmer representative. The briefer smoothly flipped his chart and explained how well things were going. Everything, quote, exceeded specification. But at one point, a member of the audience questioned that claim and said, surely the real meaning of that chart was that the experiment failed specification. That's right, said the briefer. It exceeds specification in a negative direction. And on he went. Lack of communication, an unwillingness to reveal bad news, the impenetrable corporate wall that separated Perkin-Elmer from NASA, the exclusion of scientists from a central role in major decisions. These were some of the causes leading to the fiasco. And Senator Mikulski was able to lead the congressional investigation into this problem because she had in her hand a book that thoroughly explained how it could have happened. So we historians cannot predict the future, but when the future arrives, we can explain why it looks the way it does. Okay? In this case, as we know, the outcome was a happy. A mission to repair the Hubble and replace the instruments was made in 1993, and Barbara Mikulski remained a very strong supporter of Hubble and of science in general. So to conclude, I just would like to underscore the richness of the historical enterprise, its capacity to contribute to an understanding of science in so many ways. And Jed has been a real leader in developing our field. Through his work at Toronto, where he trained many of today's faculty, especially in history of physics and mathematics, Through his leadership at the Dibner Institute at MIT, with its extraordinary range of workshops covering so many subjects, and through his work here at Caltech, which we've just learned will continue with a new institute, he's had an exceptional leadership role in promoting and maintaining the history of science as the central component of science studies. So thank you for that role. Thank you very much.